Hello and welcome to another chemistry topic together. Go ahead and instead start setting up your focus notes page. You can see that our topic today is molar mass compounds. Fill in whatever date it is you're taking these notes. And our essential question today is, how do I find the molar mass of a compound? Remember, you only need to write down the stuff in red. That's your guided notes that you need. And then anything else is just things I want us to talk about, things I want you to listen or think about. All right, so molar mass is the thing we talked about at our last time together when you did that video lab with the aluminum pieces and a molar mass of an element. So go ahead and jot this down just so you've got it in your notes. Molar mass by definition is the number of grams in 1 mole of a substance. So no matter what the substance is, it will always be 1 mole. And the number of grams, remember, for the element comes from the periodic table. We'll review that in just a bit. But the definition of molar mass is using this thing called the chemistry mole, which is a grouping word, compared to grams, which is something we can measure in the lab. So this is a chemistry vocab term, but then grams is something that's really practical. So it's nice to be able to connect those two things no matter what substance we're talking about. In the lab, we focused on aluminum pieces, right? But it could be any element. So for example, to find the molar mass of any element, so jot that down, is the atomic mass from the periodic table rounded to 2 decimal places. We keep those 2 decimal places to give us a good number of sig figs to show how much was measured, but we only keep 2 because if you look at a bunch of different periodic tables, like whether you're looking at one that I gave you or one you looked up on the internet or found in a textbook, generally if you go to 2 decimal places, all periodic tables are pretty close to the same answers. Once you go out farther than that, there's a lot of variation, and so it's just not very certain past 2 decimal places. So for example, the molar mass of boron, if you find boron, it's number 5 on the periodic table. The molar mass is 10.81 grams for every 1 mole. That's the molar mass. This number was from the periodic table, the atomic mass for boron. Molar mass of sulfur, sulfur is element number 16. The molar mass is 32.06 grams per mole. So then if we had an element like bismuth, bismuth happens to be number 83. This is what its symbol looks like. So if you were given this as the atomic mass, so what would its molar mass be? See if you can figure it out before I show you what would be the molar mass. Yeah, 208.98 grams per mole, because we always go to those 2 decimal places. The 0 doesn't round this 8, so it just is 0.98 then. So again, molar mass of an element is you look at the atomic mass on the periodic table, rounded to 2 decimal places, and then now you have a conversion between grams and moles to use in a lab or experiment setting. Of course, this is very specific to chemists, but that's the skill that we're learning right now. All right, so then what would be your prediction to find the molar mass of a compound? Think about that for a little bit. If I find the molar mass of an element by looking at the periodic table atomic mass, what do you think we do for the molar mass of a compound? Well, a compound is just elements connected to each other. So maybe you start with the formula. The formula might be given, but if it's not, you have to write out the formula. So you might have to balance charges or use prefixes, but first you get the formula. Once you have the formula, you find the atomic mass of all those different elements in that formula. If there's 2 things or 6 things or however many there are, find the atomic mass on the periodic table for all of the elements that were in that formula for the compound that you wrote. Then you add them all up. Maybe that's what you were thinking. You're like, oh, if I want to find the molar mass of a compound, I add up all the individual element molar masses. That's what you do. You need the formula, the individual atomic masses, add them all up. So for example, do this example with me, sodium sulfate. All right, well, first we need to write the formula. Sodium is a metal. It's on the far left of the periodic table, meaning I need to write balanced charges or oxidation numbers. Sodium is Na and has a +1 charge because it's giving away 1 electron to be stable. Sulfate is your hint to look on the ion guide sheet that will tell you, oh, sulfate is SO4. But sulfate needs to gain 2 electrons. So we need to give away more than we're gaining right now. So that means I need another sodium, another giving away so that sulfate can take 2 of them, Na2SO4. All right, quick, just to make sure you've got access to them. If you look on our Schoology page, there's a folder called Guide Handouts. There's a periodic table in there. There's an ion guide sheet in there. So if you don't have those, why don't you pause the video quick and go download those into your Notability right now. So again, find the folder on our Schoology page called Guide Handouts, download the periodic table, download the ion guide sheet, make sure those are Notability so you can find them. So sulfate was on the ion guide sheet, and then we figured out the formula. So that's step one. Now we have to find the atomic masses of all the elements, and that's from the periodic table. Sodium is 22.99. It doesn't round up any more than that, 22.99 grams per mole. But look it, there was 2 sodiums, remember. So we need to times that molar mass by 2. Then we have S. So S is part of sulfate, and the molar mass is 32.07 grams per mole. And then there's oxygen. Now, oxygen rounds up to 16, and it's important that you keep the 0.00 so that you have 1, 2, 3, 4 sig figs instead of just calling it 16, and that would only be 2 sig figs. All right, but then there are 4 oxygen, so we times that by 4. So 2 times the molar mass of sodium, 1 molar mass of sulfur, 4 times the molar mass of oxygen, and we add all of that up, do that, check your work, you should get 142.05. So still just 2 decimal places because molar mass is always 2 decimal places. All of these had 2 decimal places, so that's where we rounded off from our calculator. That is the number of grams for every mole of sodium sulfate. So same math, same conversion idea as before. It's just that now we can use compounds instead of just elements. All right, let's practice this. Example time. Here we go. Ready? How many moles are in 35 grams of C2H2? All right, so now this is where we start to put dimensional analysis into our chemistry work. Start with your given, so write that down first. 35 grams C2H2. This happens to be called ethene. It's a type of fuel. 35 grams of C2H2. I want grams to cancel because I want to get to moles. So I need to find a conversion that has grams in it, preferably grams and moles. Oh yeah, that's molar mass, grams and moles. But I need to find the molar mass of C2H2. So I've got carbon, which is 12.01 from the periodic table, times 2. Hydrogen, which is 1.01 from the periodic table, times 2. Add all of that together equals 26.04 grams for every 1 mole. Okay, so grams needs to cancel. So remember in DA, that means it has to go in the opposite spot. It's on the top right now, so I need to put it on the bottom in the next step. And then 26.04 is equal to 1 mole. This slash means these two things are equal to each other, top and bottom. So here's on the bottom, 26.04, so I need to put 1 mole of C2H2 on the top. Grams will cancel. I'm left with moles of C2H2, which is what the problem was asking for. So I'm ready for my equal sign. Multiply numbers on the top, divide numbers on the bottom, get a number on your calculator. This is what you should have gotten, but this is way too specific. We can't have an answer that's more specific than our least specific measurement. This only has 1, 2 sig figs, so I can keep 1, 2 in my answer. I look at this number for rounding, which it does not, so these just chop away. They never existed in science. We didn't earn them. And the final answer is 1.3 moles of C2H2. So 35 grams is something we could measure out in lab, and then we could relate it to moles, which is something that's useful for chemistry. Plus, we practiced some math work in chemistry as well, which is always good for our brain. Okay, let's try one more. Example time. All right, here we go. How about this? How many grams are in 5.0 moles of carbon dioxide? So I'm going to start with my given. That's always a good place to start. So you've got the problem started. 5.0 moles CO2. All right. I want to cancel moles and get to grams, so then I need to find the molar mass of CO2. Carbon dioxide, that's why it's CO2. I look up on the periodic table, carbon is 12.01, just one of them. Oxygen is 16.00, but this is times 2 because it's CO2. I add all of that together and I get 44.01 grams per mole. Now I'm ready to keep going with my problem. I want moles to cancel, so I'm going to set up my brackets, set up my conversion. Moles will need to go in the opposite spot. So if it's on the top now, it goes on the bottom in my conversion. So the mole is just 1. So when there's no number written, remember 1 is implied. And then that's equal to 44.01 grams of CO2 on the top. This time, moles will cancel. I'm left with grams, which is what the problem was asking for. So I'm ready for an equal sign. Multiply numbers on the top, divide numbers on the bottom. You get a calculator answer. But then we have to think about the science answer. What of this have I earned? Well, this has 1, 2, 3, 4 sig figs, but this only has 1, 2. This is an exactness 0. So I can keep 1, 2 sig figs. I look at this number for rounding, which it does not, but it stays as a 0 placeholder. These go away. So the final answer is just 220 grams of CO2. So then again, this is something we can measure in lab related to something we talk about in chemistry. So something that would be a little bit more practical. All right. So there was a couple examples kind of showing you how to use molar mass of a compound in our DA problems. And guess what? That brings us to the end of today. That's the end of your new learning. So I didn't do any Costa questions during our notes because they were kind of short. So go back and do your Costa questions now. In that same guides handout folder in Schoology, the Schoology or the Costa question guide is in there if you need hints about some sentence starters for good Costa questions. You could also do a summary for today. Summarize, how do you find the molar mass of a compound? And then your assignment for today is a little assignment where I measure a piece of chalk before I do anything. And then I write my name, Ms. Killinen, with that piece of chalk. And then I measure that piece of chalk after, and I can subtract the difference. The difference between the before and after chalk is the amount of chalk I used to write my name. And so then we can measure that in grams, and then you can convert that. How many moles of chalk does it take to write the name Ms. Killinen? So that's what that assignment is. It practices the new information from today and also just a little review of DA. So submit that assignment, make it due today. So if you have any questions, come to my office hours. Otherwise, we will see you at our next Zoom. Thanks so much for your focus and continual learning of chemistry. Bye.